As we look at this integral with this rational function, I see that we have a repeated quadratic. So this isn't going to be real fun to do, but it's doable. So let's do the partial fractions. So we have 1 over x times x squared plus 4 squared. So there will be a fraction with x as a denominator, a fraction with x squared plus 4 squared, but then we also need one more fraction that will have x squared plus 4, because anytime we have a repeated factor we need each lower power in there, because bottom line we need any possible fractions that when combined would have this denominator, and you see the common denominator between these three is this. The numerator then, this will be an a, because the denominator is a quadratic here we need two terms, one with an x and one not, so bx plus c. Same thing here, so we're going to need dx plus e. Now let's go ahead and clear to fractions. So if we multiply by this denominator, this will cancel. The x will go here and leave x squared plus 4 squared. On this one, the x squared plus 4 squared will go and leave us x. And on this last one, one of the x squared plus 4's will go, so that'll leave us an x and an x squared plus 4. Now we're going to use the method of equating coefficients, so we need to multiply everything out. So this is 1 equals this multiplied out multiplied by a. That's going to be a x to the fourth. The middle is going to be 8x squared multiplied by that a, so 8a x squared. The last is going to be 16 and multiplied by the a. Here we'll distribute the x through, plus b x squared plus cx. Here we'll distribute this through, which is going to be x cubed plus 4x, and then that will need to be FOILed here. So that's going to be plus dx to the fourth plus 4dx squared plus ex to the third plus 4ex. Pretty long, but not going to be too bad now to equate coefficients. So what that means is any terms on the left-hand side, types of terms, have to equal the same types on the right. So first we're going to look at x to the fourths. There are no x to the fourths on the left. On the right there's an a for a coefficient plus a d. And I'm going to go ahead and cross these off so I know I've used them. It'll help me keep all this straight. So x to the thirds, there's none on the left. On the right, it looks like there is an e on an x to the third. Now I'm going to look at x squared, none on the left. On the right, I have an 8a on an x squared, plus a b on an x squared, and plus a 4d on an x squared. Now I'm going to look at x's, none on the left. On the right, I have c plus 4e. And then I'm going to look at the constants, so the things without x's in them. On the left I have 1, and on the right I have 16a. So as we do this, see that I have a system of 5 equations and 5 unknowns, but they're pretty simple, so it's not going to be too hard to do. I actually already know e, and if e is 0 I can put that in here, and I already know c is also 0. Down here at the bottom I can solve for a. A is 1/16. And if I know a, I can easily solve this first one for d. That's going to be negative a, so negative 1/16. And then here I can find b by moving this over, negative 8a, and a was 1/16, so 8/16, so that's going to be 1/2, and then minus 4d. But d was negative 1/16, so that's going to be plus 1/4. So it looks like b is going to be negative 1/4. Now that we have all the pieces, we can go up here and we can write the partial fractions. I'm going to get this out of the way so I've got room to write that. And so a was 1/16, so I've got 1/16 over x. And then b was negative 1/4 and c was 0, so that's going to be minus 1/4 x, and that's c part was 0, and then this is x squared plus 4 squared. And then we've got d is negative 1/16, and e was 0, so that's going to be x over x squared plus 4 dx. Okay, let's see what we can do to integrate each of these. So looking at this one, we have 1/16 natural log absolute value of x. As I look at this middle one, I'm going to go down here to work that, and I'm going to do a u substitution. I'm going to let u be x squared plus 4. So that means du is going to be 2x dx. As I look here, I don't have a 2, so I am going to make this 1/2 and move this over here. And I'm actually just going to work this part, and then we'll put the minus 1/4 on there in a minute. So if I'm doing the u substitution, the x dx can be replaced with 1/2 du, and then I'd have 1 over u squared. So doing the integration, that's going to be negative 1/2, and we've got a u down here. We'll put the constant of integration on in a minute. So replacing the u, that's going to be negative 1 over 2, and then x squared plus 4. So we'll put that in up here, and we also have to multiply it by the negative 1/4. So that's going to be negative 1 over 8 times x squared plus 4. Now if I look at this third one, I'm going to do the negative 1/16 in a minute again. And so I can do a u substitution again using the same thing. So I'm going to have a 1/2 integral 1 over u du. So that's going to be 1/2 natural log of u, but u was x squared plus 4. Now as we put that in, we still had the negative 1/16, so that's going to be negative 1/32, and natural log of x squared plus 4 plus a constant. And I see one mistake here. This was a negative, and this was a negative, so this should be a positive. There we go.